Hi friends, in this video let us learn about small signal equivalent circuit of MOSFET. So before learning this, we must know how to draw the AC model of the MOSFET. So for that, we take one common source circuit. Let us assume this is drain distance RD. We have one common source NMOS. So this is NMOS transistor. Here we have source Vi and DC source VGSQ, and I write properly. It is VGSQ, and here the source is ground. This is source, this is gate, this is VGS plus and minus. The current flowing through the drain resistor is ID. Right, so to find AC equivalent circuit, what we have to do is short DC source or remove DC source. If it is voltage source, short it. If it is current source, open it. Right, so I have to remove. What are the DC source here? This one and this one. So AC equivalent will be like this. So this is, I have only AC source. DC, I make it shorter. Then it is this one. VGS. So this is this. Here we have RD, and this is 0. This is short. Okay, so this is the typical. This one. This is ID. Okay, otherwise I draw like this. If you have a confusion, so this RD, this is ground, VDD is good. So here current flowing through this is ID. So it is drain, gate, source terminal. Okay, so this is typical AC equivalent circuit. So we removed this one and we removed this one. Okay, so we know that here, what is the thing? Here VGS is VI. Here the input is VI. So these are all the parameters we have now. So this is VGS. VGS is nothing but this voltage. So that is the first thing we have to remember. Next, what is ID? We know already. Drain current in terms of gate to source voltage. The reason is we know transconductance GM is equal to ID by VGS. This is output current. This is input voltage. Input voltage is nothing but VGS. Output current is drain current. So that is the first thing. Then we have to find what is VDS. So these are all the three AC parameters. What is VGS? It is VDS. So VDS. VDS is nothing but this current is going like this. So VDS is VDS. This is VDS. But ID flows like this. So VDS is equal to minus ID RD. All are small AC parameters. So I used small letter. Right. So this is small only. Everything is small. So all current and voltages are small. Okay. So this is ID. I put ID because VDS is plus minus. So current flows in the opposite direction. So I put minus RD. So this is the way AC equivalent is drawn for MOSFET. Now, after knowing this, we will go to small signal equivalent. Small signal equivalent. How can we draw small signal equivalent circuit? So the small common mode, it is common source. Let us take common source NMOS. How we are going to draw small signal equivalent? So this is common source, right? So this is drain, gate, source, common source NMOS. So we know that the voltage between gate and source is VGS. So This is VGS. The voltage between drain and the sources, VDS. So this is VDS. Now we are going to draw. So we know that the gate is insulated in MOSFET. That means gate current is 0. So the input voltage is 0. Right? So that is the point we have to, sorry, IG 0. So it is open circuit, right? So input side it is open. Gate current is 0, so it is open in nature. R is equal to infinity, right? So in output, what is output current? ID, right? Drain current. We know ID is equal to, just now only we saw that ID is equal to GM into VGS. Now we see how we are going to draw. Input side, common source. Source is a common terminal between input and output. So source is, this is source. This is gate, right? So input side it is open circuit. So we have only VGS. It is VGS. Fine. There is no current in the input side because gate is insulated. In output side we have current which is dependent on voltage. So it is a current ID, that is GM/VGS. This is D. So DGS common source. So this is the small signal equivalent of NMOS common source transistor. So NMOS, small signal equivalent of NMOS common source, right? So input side there is no current, so it is open. Output side current is ID is equal to GM/VGS. So this is the way we have to draw a small signal equivalent. So here we know that, let us assume the transistor, sorry, this configuration in saturation. In saturation we know ID is equal to Kn VGS minus VT whole square. We include what you call channel length modulation parameter. So what is RO? This we know already. The output resistance due to channel length modulation is given by dou ID by dou VGS inverse, right? So if you have any doubt, please refer my video on channel length modulation. So if I differentiate this, what I get is lambda into Kn VGS minus VT, right? So sorry, VDS, it is not VDS, it is VDS into what do you call lambda. So that's what you have done. Okay, so lambda VDS is 1, so lambda into Kn VGS minus VT square. So what is my Kn VGS minus VT square? That is whole universe. ID by VDS is this one. ID by VDS. I differentiate this with respect to VDS, so this will be a constant. 1 plus lambda VDS is lambda 1. So you see this is drain current. So sorry, right, so it is lambda ID cube, right? So this is inverse, lambda ID inverse. So R naught is equal to 1 by lambda ID. So if we include channel length modulation, we have to include this RO in the small signal equivalent. So now the small signal equivalent will become like this. What is that? It is GM/VGS. This is VGS, gate, source. Now we are including R naught. This is the resistance due to channel length modulation, that is equal to 1 by lambda ID. So it is VDS. This is drain. Here we have VDS, right? So if channel length modulation is 0, that is lambda is equal to 0 means R naught is equal to infinity. At that time we can neglect this. That's what we have done here. Here we didn't include channel length modulation, so it will become open circuit. Here we have included. So it is one, not infinity, it is some finite value. So R naught is equal to 1 by lambda ID. So this R naught is due to channel length modulation. If you want detail about channel length modulation, please may refer my video on channel length modulation. Right? Okay. So this is this one. Okay. Now let us see how to draw the small signal equivalent of. This is a small signal equivalent of the transistor. Now we have to draw the small signal equivalent of the our common source configuration. What is that? For this configuration, you see. For this we have to draw. This is AC equivalent. For this we have to draw. Here you see this point. Here here we have to. This is for this we have to draw the small signal equivalent. We have drawn the small signal equivalent for this MOS transistor. This is not included. This is outside. So we have developed a small signal equivalent for this transistor only. This is outside. So VA will be outsider, RD will be outsider. This is a small signal equivalent. Let me draw for this diagram. Okay. So how we are going to draw? In input side, what we have? Here input side we have only VI, right? And that is the only thing we have in AC. So after that, what will happen? Now transistor is there. Instead of transistor, we draw small signal equivalent, which is nothing but VGS. Right? Then here GM VGS. This is GM VGS. Next, if we include R naught, that is channel length modulation, we will have R naught, and up to this the transistor is over. After that, what we have? The external resistor RD, that is drain resistance. That's it. So here VDS. This plus minus. So this is the small signal equivalent of the common source configuration we have taken. You see, this is the point. Instead of NMOS transistor, we have included this point. This is the output side. This is input side. This is output side. This is the transistor, right? So in this way, we can draw the circuit. So from this, how can we find the gain? Small signal gain. We know what is VO. VO is this one. So drain current is GM/VGS. So this current flows here, right? So what is my VO? VO is minus GM/VGS parallel RO parallel RD. In the parallel combination, the drain current flows. So what is VGS? VGS is equal to, we know, input. VGS is input voltage. That's what we have studied in AC parameter. So what is VO by VI? That is AV. So small signal gain is minus GM RO parallel RD. This is very, very important equation. So this is the small signal gain, voltage gain, small signal voltage gain. Okay. So you see, we know that from this what we are understanding is GM is normally very small. GM is very small. So the voltage gain of MOSFET is small. Right? So and another thing you see, we have one minus here. This indicates 180-degree phase shift between input and output. That is common source introduce 180-degree phase shift between input and the output. So that's all about this session. If you have any doubt, please ask me in comment section. I will clarify. Thank you.